Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. My name is Jessie, and in today's episode 1.2, Motoko Level 1, we're going to be going over the basic syntax and basic functionality of the Motoko programming language. If you recall from our previous module, Introduction to Languages, we discussed that Motoko is a programming language that's been developed and optimized specifically for developing programs on the Internet computer. Recall that programs come in the form of smart contracts on the Internet computer, and those smart contracts are referred to as canisters. In this version of the developer journey, we're going to be primarily using Motoko for building our applications and our programs. So it's important that we understand the basic concepts and terms in order to properly grow as a Motoko developer in this journey. So for this tutorial, we're going to be following the 1.2 Motoko level tutorial that is in the developer journey. You can go to the developer documentation and navigate to the developer journey tab, and this level is located in level 1, 1.2 Motoko level 1. For this tutorial, instead of having a terminal window open, we're going to have our VS Code or other IDE open so that we can write out the bits of code that we're going to be looking at to help further understand it. This is optional if you just want to sit back and observe this tutorial, but if you want to follow along, it is important to have a code editor open. We do recommend VS Code since there is a Motoko specific VS Code extension available that is helpful in highlighting different portions of the Motoko syntax. You can see that I have this installed here in my version of VS Code. Then to get started, I've opened my developer journey directory, which currently contains the Hello World sample project that we explored in the previous tutorial, 1.1, Exploring a Live Demo. You can open this by going to File, Open Folder, and then navigating to the developer journey subdirectory that you have. So to get started, let's talk about some of the basic concepts and terms that are important when talking about the Motoko programming language. So if you recall, within Motoko, the term actor is used to refer to any canister regardless of that canister's language. Motoko is designed specifically to make actors easy to write and use once the canister has been deployed. Each canister smart contract can only contain a single actor. So with actors in mind, there are a couple other terms that you will need to know in order to be familiar with the rest of this tutorial. The first of these terms is a declaration. So a declaration in regards to Motoko is used to define immutable variables, mutable state, objects, actors, classes, and other data types. So declaration refers to a definition of a data type. An expression in regards to Motoko is used to describe different computations that involve those declarations. And then a program is a collection of those expressions and declarations. So a declaration is a definition of a data type. The expression is going to be anything that describes a computation using those data types. And then the program is going to be the combination of both expressions and declarations. When talking about Motoko, the term value represents any entity that can be manipulated by the program. And a variable refers to data that can be stored or referenced and then manipulated by a program. Variable is a term that is used across many different programming languages, so that one may already be familiar to you. And then lastly, a type in regards to Motoko makes a precise prediction regarding the program's result. So we're going to be talking about these more as the tutorial goes on, but just for some high-level definitions, these are in this tutorial for you to reference later. So next, let's move on to the Motoko syntax. So the syntax uses declarations and expressions, and as we just saw, a program consists of those expressions and those declarations. And one of those expressions is an actor expression that is introduced using the keyword actor. So to get started, before we define entire programs, let's look at some simple declarations and expressions without having an actor defined. So our first example here is an example of a declaration. And so while it's available on the tutorial here, it is beneficial to type it out yourself in a code editor. So that's why we have VS Code open. And so I'm just going to create a new file in our working directory here. I'm just going to call it main.mo. And so .mo is that file extension indicating that it is a Motoko file. And if you have the Motoko extension installed, you'll see that it gives you the little Motoko ghost icon to indicate that it is a Motoko file. And so to get started with a very simple display of the Motoko syntax, we're going to define a declaration by using the let keyword, and then we're going to just use the value of x, and then the equal sign, and then the value of 1. And we're going to close that with a semicolon to end the line. And so this is just declaring that this character x is equal to the numerical value 1. And if you have the extension installed, you can hover over the different points of the syntax and get some information. Like if you go over the 1, you can see that it is of value nat. That indicates the type of data that it is, and we'll talk more about data types in the later portion of this tutorial. But for right now, that will be our first line. And then we're going to create a second declaration, and this one is going to be let y, so that's going to be a different character, and we're going to have that equal the value of x plus the value of that number 1, and then we'll end the line again with a semicolon. So these are two forms of declarations since they are defining different data types. Then we're going to follow this by an expression. So we will do some computation using the values x, and we'll do it times y, times being indicated by the asterisk, times or multiply. And then we'll use the plus to add x again, and end that with a semicolon. So this first one, this is a declaration. The second one is also a declaration. And then this last one is an expression. And so all together, since now we have a mix of declarations and expressions, together this is a single program in Motoko. So like I mentioned, this value of 1 when you hover over it, and when you hover over these other variables, since these variables are defined to equal this value of 1 or some variation of this value of 1, such as y equals x, which is 1 plus 1, so y ends up equaling 2. All of these variables end up equaling a data type known as nat that you can see when you hover over each one. And a nat refers to a natural number. So since these are whole numbers, they're just numerical values 1 and 2. And then on the bottom here, this expression ends up equaling 3. We're only dealing with natural numbers, and that can be seen by hovering over each of those. So if we want to amend this code to introduce another variable, we can amend the original program by going to the top here, and we're going to use the keyword let again, and then we're going to use the value of z, and we're going to set that equal to a do function. So we're going to use the keyword do, and then we're going to use a curly bracket. Now, because these are going to be within this function of do, we're going to indent each of these lines and then close it with a curly bracket at the end and a semicolon. So now all of these end up equaling z. So at the end, this expression here is equal to the value of 3. So that means that the output of this expression is now stored in this z value. So that is just a very, very basic introduction to the Motoko syntax. Another important portion of the Motoko syntax is the base library. So Motoko is designed to minimize the amount of built-in types and operations. So whenever possible, Motoko uses the base library to provide necessary operations and types for developers to utilize. So the base library is a core function of Motoko. It includes a selection of modules that focus on Motoko's core features. So to use the base library, you're going to need to import it. So this is similar to importing packages and modules in other programming languages. At the top of the file, we're going to use the keyword import. And for this example, we'll import the debug module. So we'll import debug. And then we want to import from the Motoko base library. So we're going to use mo, which is short for Motoko. Then the keyword base to indicate the base library. And then the module from that library that we want to import. So that debug library. And then we'll close that with a semicolon. Now that we have that debug library imported, we're going to use it at the bottom of our code by referencing it with the word debug. And then we're just going to want to print some values to the terminal. So we're going to use print, then we're going to use a parenthesis, and we're going to use debug underscore show, and then another parenthesis. And now we're going to use z, since we want to print out the value of z, which should be the result of this expression here. And then we'll close that with a semicolon, and then we will save this file. You can use Command S, or you can go File, Save. And now we're going to open two terminal windows. And so I'm just going to make these a little bit bigger. So in the first terminal window, we're going to start DFX. So we're going to do DFX start. And we aren't going to use the background flag this time, since we want all of the debugging output to be shown in the terminal. So we're going to use DFX start. And so we're going to see that that got started properly, and we can see that we're on version 15.1. I'm just going to make that a little bit bigger. And since it's not running in the background, it's running in the foreground in the terminal, we aren't going to be able to type anything else in this terminal, so that's why we're going to need the second terminal. And now here we're going to navigate into our working directory. So for me, that is this developer journey directory, and we'll navigate into that. And then we have our main.mo file here. So now to run this, I'm going to navigate into my working directory, which is this developer journey subdirectory that is in my user's home directory. So I'm going to use the tilde shortcut and then developer journey. And then if we do an ls, we can see that main.mo file that we've been working on in our IDE. We can see that is reflected over here. I'm going to make this one a little bit bigger too. Then we're going to use DFX new, and we're just going to call this Motoko level 1. And it will create a new project using the default DFX template. And we'll just wait for that to go ahead and install. And then we're going to still see our main.mo file here, and we're going to want to move that into our newly created backend canister. So then we're going to want to move, or mv, that main.mo file, and we want to move it into Motoko source backend, and we'll move it there. So that's going to be in Motoko level 1 /src /Motoko level 1 backend. And then if we do an ls of that directory, we should see that file. And if we do a cat or concatenation, we can take a look inside that file. And we can see that it contains the same output as this here. And you'll see that now in my IDE, I have, since I've moved it, it's showing me that the file is no longer existing where it was, and that is true since it's now moved into this Motoko level 1. So now we're just going to reopen it here. And then we'll use DFX deploy. And I'm not in the correct directory. So then we'll move into that Motoko level 1 directory, then we'll use DFX deploy. And now in our terminal window that we still have DFX running over here, we should see the output, but we don't since the file contains no main service. Okay, so let's go ahead and add in an actor. And we're going to need to put this inside the actor, and we will talk about actors in just a minute, but let's see if we can get this running first. Let's run DFX build again. Okay, and so that was the issue since this didn't have this actor defined within this main.mo file. And like I said, we'll talk about actors a little bit later in this tutorial, but for now, let's just go ahead and get this running. So let's run DFX deploy, and we can see that everything gets up and running now and gets installed. And then we can see our output in this terminal over here that's running DFX. And then we have the URL for the just default front end canister that's included with projects that are created with DFX new, and then we have our backend canister. And we can see that our debug output was shown here at the end of 3, and this doesn't give us a whole lot of indication that that's where that 3 is coming from. But we can go ahead and check to make that value change. So let's change X to 5 and save the file with Command and S. And then here we can run DFX deploy again to redeploy the canister. And now we can see that we've changed this value to 5, and now the canister is outputting 35. We can go ahead and change this value and run DFX deploy again after saving the file again. And now we can see that that is now changed to 75. So now let's go back to our tutorial, and we're going to use the debug library to print out some text now instead of a result of an expression. So we're going to get rid of all of this, and we're going to use debug.print, and then we're just going to say hello world and close that with a semicolon. Now if we save this and we go to try and run this again in our terminal window, if we use DFX deploy, it's going to give us that error again saying that it doesn't contain a service, and that's because we got rid of that actor. So we're going to need to put that actor back in and close it and save the file again. Now if we use DFX deploy and if we open our window for where DFX is running, we can see that now this returns hello world. So when you want to run the code as a canister, you are going to need this actor keyword that has these curly brackets around the bit of code. And this is important because it tells Candid what to define as the service in the canister. Now recall that a canister can only contain one actor, but the actor can contain several services within that actor. So we're going to get rid of this for now because we are going to dive back into looking at the Motoko code. But just as a note, if you want to run any of these other examples that we'll be going through in the terminal, you will need to have that actor keyword wrapped around the code to run it. Otherwise, you'll get that no service error. So in this example, we are importing something from the Motoko base library. You can also import Motoko code and other modules using their relative paths. So instead of referring to the library through the prefix of mo:\base, you can also use a relative file path. So if you have a program called types.mo that contains some other program functionality that you want to import into your main.mo file, or another program within your project, you can use the relative path, such as if we wanted to import something called types, we could do import types, and then we can use the local relative path of types. And this would be stored at the types.mo file, but since we are importing from a local relative path, we don't need to include the file extension of .mo, so we can just use import types, and then the relative path, in this case, this would be the current working directory, and then that file types.mo. So previously we looked at the example using declarations and expressions, and we took a look at how we were able to use the immutable variable x, which was defined via the declaration let x equal 1, the immutable variable y, which was defined via the declaration let y equal x plus 1, and then the implicit variable that holds the final expression x times y plus x. And so that last expression illustrates a more general principle that expressions can be thought of as a declaration whenever necessary, since the Motoko language implicitly declares an unnamed variable with that expression's result value. And we talked about how the term nat refers to natural numbers, which consist of whole values such as 0, 1, 2, 3, and nat values do not have a maximum size, so there is no maximum value for a natural number. So as we saw with our basic example with the declarations, Motoko permits standard arithmetic operations, and we saw that in our very basic example where the expression ended up equaling a natural value of 3. So we can also take a look at this more complex arithmetic example where let x equals 42 plus, then we'll use parentheses, 1 multiplied by 37, and then we'll divide that by 12. And again, we can hover over each of these and see that these data types are natural numbers, and the result of this arithmetic expression will be a value of 42. So when we talk about expressions, expressions can also be formed using a block. So a block of expressions can be used by enclosing a list of declarations within curly brackets. And so we did that earlier when we used this example of when we had let z equal, and then we had this expression of do, and we had all of those the two declarations and the expression that we put into that curly bracket. And the reason that we put it into this do expression is that it allows our code to remain a functioning program, but now our declarations of the values x and y are privately scoped within the block expression. So that means that you can define x and y in different portions of the code outside of this block expression. Now we can also elaborate on this further, and we can make a larger compound expression by starting with a value such as 100 plus, and then we can get rid of the z portion and indent everything over. But then we're going to need to put some parentheses around our do function to put it into this larger compound expression. And we can see that the nesting of these blocks, so this expression block and then this expression block, is nested into this expression block, which is within this expression. We can see that this preserves the autonomy of each separate declaration list and its variable names. So when talking about program languages and their design, this is referred to as lexical scoping, which is where a variable scopes may nest, but they do not interfere with one another as they do nest. So we can demonstrate this further with a more complex series of declarations and expressions. So let's start out with let x equal 40, and then we'll let y equal 2. Then we're going to ignore, and then we're going to use the do function and the curly brackets, and we will put in our original declarations of let x equal 1, let y equal x plus 1, and then x multiplied by y plus x. And then we will close our curly brackets, and then after all of that, we will do x plus y. And so here we define the values of x and y at the top. Then we have this block expression, and we are using this keyword ignore. So everything in this block expression is going to be ignored. And then we have x plus y at the bottom. So the total value of this is going to be 42, since we're going to be using these values x and y up top here. So 40 plus 2 is 42. And so everything within this is being ignored by that ignore keyword. So aside from just giving programmatic clarity, the benefit of lexical scoping is program security, since it can be used to build compositionally secure programs. Motoko specifically has very strong compositional properties, since nesting programs within another program cannot arbitrarily redefine your variables to have other meanings. So this is one of the key design features in the Motoko programming language. So now we've just looked at some brief declarations and expressions, and we also looked at how to import the base library. Now let's go into defining an actor. So we're going to keep all of our code since we're going to use it in the next step. First, we are going to define our actor. So we're going to use the actor keyword, and we can give the actor a name if we wish, but for this example, we won't name it, we'll just use the actor keyword. And then we're going to use a curly bracket to define the content within the actor. So remember that an actor is a process with encapsulated state that communicates with other running actors, and a smart contract canister can only contain a single actor. So now that we have our actor definition at the top, we're going to format our example code to properly be defined within the actor. So we're going to indent everything over, and we're going to make sure that we close our actor definition with a corresponding curly bracket. And so now all of our values within the actor have been defined, and the result of this actor is still going to be this x plus y value, which equals 42, because we haven't made any changes to our ignore block expression here. So now we're going to briefly talk about some of the values and their evaluation in Motoko. We talked about natural numbers, which are defined by type nat, and that you can see by hovering over values that have type nat in VS Code. But there are several other different types of data values in the Motoko programming language. So first, there are Boolean values, which can either hold the value of true or false. There are also integers, which are like natural numbers, but they include the negative variations of each. So natural numbers do not include negative numbers, they only include numbers higher than 0, whereas integers include numbers less than 0. There are also text values, so these are strings of Unicode characters. And these 4 types of values, Boolean, integers, natural numbers, and text values, these are referred to as the primitive values of Motoko, and these are predefined by the language and they're named using reserved keywords. Then we have non-primitive values, so these are values that Motoko supports that are user-defined, but they do not have specific reserved keywords to describe their data types. So there are tuples, arrays, objects, variants, function values, async values, and error values. And so these non-primitive values we will dive into deeper in the future versions of this tutorial. So in this developer journey, there are Motoko levels 1 through 4. So this is Motoko level 1. So in Motoko level 2, 3, and 4, we will dive into these non-primitive values further. But for now, it's just important to understand the difference between primitive values and non-primitive values and to understand what the primitive values are. So earlier in the tutorial, we looked at this example of import debug, and then we imported the debug library from the Motoko base library, and then we used that debug library to print the value hello world. So in this example, the print function accepts a text string of the value text as the input and returns the unit value of unit type or parentheses as the output. So unit values do not carry information as all values of unit type or parentheses are identical. Therefore, the print function does not return any interesting result. Instead, the print function is able to return the input text string in a human readable format in the terminal window, and this is referred to as a side effect. So functions such as print have a side effect such as modifying the state of the canister or the program or returning output to the terminal, and these are known as impure functions. In contrast, a pure function is a function that only returns values and does not provide additional side effects. So now let's take a look at transforming a Motoko value into a human readable text string that can be used for program debugging. So we're going to head back to VS Code and we're going to clear our previous examples and we're going to use that same import debug mo base debug statement to import that debugging library from the Motoko base library again. And now we're going to do debug.print and we'll use the command debug _ show. Then we're going to use double parentheses, use the string hello, followed by the nat value 42, followed by the string value of world. And then at the end, we're going to need to add one more parenthesis. So then when this program is run, it's going to return the output of hello, comma 42, comma world. And this transformation function can be used to print most Motoko data types as text, which can be helpful when you are debugging a program. So next we're going to look at an example where we're going to want to pass text arguments to our function. And to do this, we're actually going to make a call to a canister. So at this point, we've just been working in this base main.mo file. It's not in a directory with DFX or any of the other development tools. So we are going to change that. So let's open up a new terminal window. And we will print our working directory and see that we are in my current home directory. And then I want to navigate into our developer journey working directory. Then I'm going to use the dfx new command to create a new project called location_hello. And we'll give that a second to run all of the creation scripts in the background and install some of the necessary node dependencies. Then we're going to use the cd command to navigate into that new hello world, or that new location hello subdirectory. And then we will print that working directory just to see that we are in my home directory, that developer journey working directory, and then this new location hello project directory. And so now we can see that in VS Code, that new directory for this project pops up. And so we're going to open the source subdirectory, and then we're going to open the location hello backend subdirectory and open the main.mo file here. And you can see that this contains the default hello world actor and program that we looked at in the previous tutorial. And we are just going to remove all of this because we are going to write our own. So we're going to start out by defining our actor, and then we are going to define a public function, so pub and then func, and we're going to call it location. And then we're going to use parentheses and use the word city, which is going to define a value that we are going to input into this function. And we want this city value to have type of text. After this, we're going to do a colon, and we are going to use the word async and then the word text, and then a curly bracket, and we'll press the enter key. And now we'll define what this function is going to return. So we'll return, and we'll return hello, comma, then we'll come outside of the double quotations, and we want to then return this value of city. So whatever is stored in city, we want to return by enclosing it in hashtags. And then we'll end the sentence with an exclamation point in double quotations again. And then we'll end the line with a semicolon, and then put a semicolon after each of our brackets. And so here we are defining a function called location. It takes an input called city, and the input is going to be of type text. And so now if we go back to our terminal window, so we're going to also want to save this file. So I'm using Command S to save it. You can also go to File and then Save. So then we're going to go back to our terminal window here, and I will make this bigger. And so we then are going to want to first deploy this canister, so we can use dfx deploy, and then we just want to deploy the backend canister, so we're going to deploy location_hello_backend. And we can see that I do not have dfx running, so we're going to use the dfx start command. We're going to use the flag clean. This just makes sure that we are starting a clean version of dfx that isn't using any local cache files or other temporary files. And then we're also going to use the flag background to send the output of dfx start to the background so that we don't need to open another terminal window. And then we're going to press enter, and we're going to start dfx. And we can see the local dashboard URL for our local replica here. And we're just going to give it a second to finish initializing that local replica. And then we can run that dfx deploy command again to access that command that we just ran right before we ran dfx start, you can use the up arrow to go through your command history. So that's what I've done here. I've just tapped the up arrow twice to get back to that dfx deploy command. We can see it's going to deploy just that location hello backend canister. And then we can see that it's been successfully deployed and we get the URL to the candid interface. We won't be using the candid interface in this tutorial. We'll just be making calls to the canister from the command line here. And so we're going to run the command dfx canister call to indicate that we want to make a call to the canister. And then we need to indicate the canister's name. So that's going to be location hello backend. And then we also need to indicate what function within this canister we want to call. So we want to call our location function. And now we can pass whatever text we want to be stored in that city variable. So for this example, let's use San Francisco. And you're going to need to enclose that text in double quotations since we have a space in San Francisco. So if you wanted to include just one word, you don't need to include the double quotations, but if you're including something that has a space, you will need to put it in double quotation marks. So we can press enter and we can see that it returns hello San Francisco. Since in our code, we have it return hello and then whatever the past text is that's stored in this city input and then an exclamation point. So we could also pass something like developer journey. And while developer journey isn't a city, it's just stored in the city variable. So we can pass any text to this and it'll return it in that same format since it is being passed into that text input. And then to demonstrate one that doesn't have a space in it, we can use the word Paris. And so since this is just one word, we don't need to put it in double quotations and it will be passed and returned in the same way. And so that is going to wrap things up for today's episode of the Internet Computer Developer Journey. If you enjoyed this video, please be sure to subscribe to the DFINITY YouTube channel in order to be notified whenever the next episode of this Developer Journey series is released. And also give this video a like and a comment to let us know your thoughts and any feedback you have on the series. There are several resources that will be in the description of this video, including the link to the text tutorial that we followed alongside today, and also links to different developer resources such as our DFINITY Developer Discord, the DFINITY Forum, links to our working groups, and other resources to help you along your developer journey. In the next episode, we will be deploying our very first full stack dApp, which will include both a front-end interface and some back-end code that we will write ourselves instead of using the template files that we have up until this point in the developer journey. So you definitely don't want to miss that episode. We'll see everyone next time. Take care.